Have you ever wondered what happens when art collides with science, particularly nanotechnology? Welcome to the world of nano art, a realm where creativity meets the microscopic. In this sphere, nanotechnology, a branch of science that manipulates matter at an atomic scale, intersects with the vibrant world of art. This fusion has a history that stretches back decades, with scientists and artists alike exploring the potential of these minuscule particles. Stay tuned as we delve into the fascinating world of nano art. At the heart of nano art lies the tiny, yet mighty, nanoparticle. These minuscule particles, often no larger than a few hundred atoms, hold the power to transform our perception of color and light. To understand how they do this, let's first consider their physical and chemical properties. Nanoparticles are unique because their tiny size gives them an incredibly large surface area relative to their volume. This large surface area allows them to interact with light in fascinating ways. When light hits a nanoparticle, it can be absorbed, reflected, or scattered. Each of these interactions can produce different colors, depending on the size, shape, and composition of the nanoparticle. For instance, gold nanoparticles can appear red or green, while silver nanoparticles can produce colors ranging from yellow to blue. Here's where it gets even more interesting. The color produced by a nanoparticle isn't just determined by its material, it's also determined by its size. In fact, the smaller the nanoparticle, the shorter the wavelength of light it interacts with. So, smaller nanoparticles will produce colors towards the blue end of the spectrum, while larger nanoparticles will produce colors towards the red end. This phenomenon is a stark departure from traditional pigments used in art. In conventional pigments, color is produced by the absorption of certain wavelengths of light, with the remaining light being reflected back to our eyes. But with nanoparticles, we're not just reflecting light, we're manipulating it on a nanoscale level. And unlike traditional pigments, the color of nanoparticles can be precisely controlled. By adjusting the size of the nanoparticles, artists can tune the color to their exact specifications, creating hues that were previously unimaginable. In essence, nanoparticles give artists a whole new palette of colors. They introduce a level of control and precision that is truly revolutionary, opening up a world of possibilities for artists to explore. From the richest reds to the most vibrant violets, the colors of nano art are limited only by the imagination of the artist. Now let's look at the canvas where science meets art. Nanoparticles are not just limited to the world of science, they've found their way into the vibrant realm of art too. Contemporary artists are increasingly leveraging the unique properties of nanoparticles to create stunning visual effects and push the boundaries of what's possible in artistic expression. One such artist, Paul Friedlander, a physicist turned artist, uses nanoparticles in his kinetic light sculptures to create a dazzling array of colors that shift as the viewer changes perspective. His work is a brilliant showcase of how science can be harnessed to evoke emotions and provoke thought. Another example comes from the renowned artist Anish Kapoor. Known for his monumental sculptures and installations, Kapoor employed the world's blackest black, known as Vanta Black, in his work Descent into Limbo. Vanta Black, a material made from carbon nanotubes, absorbs over 99.95% of visible light, creating an abyss-like effect that Kapoor utilized to challenge our perceptions of space and depth. But it's not just about creating stunning visuals. The use of nanotechnology in art also opens up new avenues for exploring concepts of change, impermanence, and interactivity. For instance, artist Roger Hyorns uses nanoparticles in his work to create pieces that change over time due to chemical reactions, challenging the notion of art as a static entity. Moreover, the use of nanoparticles can also enhance the viewer's engagement with the artwork. Take the work of artist Daniel Knoger, who uses flexible LED screens and nanoparticles to create interactive installations. As viewers approach the artwork, their movements are detected and reflected in the patterns displayed on the screens, creating a unique, dynamic experience. The integration of nanotechnology in art is not just a fusion of science and art, but also a reflection of our evolving understanding of the world around us. It offers artists a new palette of possibilities, allowing them to create works that not only engage the senses but also stimulate the mind and challenge our perceptions. As you can see, nanoparticles truly bring art to life in a way traditional mediums cannot. Among nanoparticles, quantum dots hold a special place. These tiny particles, usually made of semiconductor materials, possess unique properties that stem from quantum mechanics, the laws that govern the behavior of particles at the nanoscale. Quantum dots are fascinating. They're like chameleons of the nano world, changing their color based on their size. That's right, the same material can emit different colors just by altering its size. This is known as the quantum confinement effect. This effect results from the fact that when particles are confined to a space smaller than their wavelength, their energy levels become discrete rather than continuous. And it's this energy difference that determines the color of light they emit when excited. Now, imagine the possibilities this opens up for art. Artists can use quantum dots to create vivid, luminescent colors that were previously impossible to achieve. Picture a painting that glows in the dark, or a sculpture that changes its color under different lights. With quantum dots, artists can literally paint with photons, the particles of light. Moreover, the color emitted by quantum dots is more stable and less prone to fading than traditional pigments. This means artworks that maintain their vibrancy over time, resisting the fading effects of light exposure. Quantum dots, in essence, allow artists to paint with light. Nanoparticles are not just about color, they're also about interaction. As we delve deeper into the world of nano art, we find that nanoparticles hold the potential to revolutionize how we create and perceive art. Imagine a canvas, a seemingly ordinary piece of artwork. But with the addition of nanoparticle-infused paints and coatings, it transforms into a dynamic spectacle, exhibiting vibrant color changes or enhanced intensity under different light conditions. This is no longer just a static image, but a living, breathing entity that reacts and interacts with its surroundings. Let's venture further and pick up a pen. Not just any pen, but one filled with nanoparticle-infused ink. The resulting drawings could interact with light or even the viewers themselves, creating immersive and transformative experiences. The lines on the paper could shimmer and shift, evoking a sense of wonder and engagement that goes beyond the traditional two-dimensional realm of drawing. And the magic of nanoparticles doesn't stop there. Artists are increasingly using these tiny particles to create art that cannot be achieved with traditional pigments. Both plasmonic nanoparticles and quantum dots have been used to create artworks with colors so vivid and unique, they challenge our conventional understanding of the color spectrum. But perhaps the most exciting application lies in the creation of interactive and dynamic artworks. With nanoparticles, art can change appearance based on the light conditions, the viewing angle, or even environmental factors. Imagine stepping into an art installation where the colors and patterns shift as you move around, creating a completely personalized and unique experience for each viewer. The incorporation of nanotechnology into art brings the viewer into a participatory role, blurring the lines between the creator and the audience. It's no longer just about looking at a piece of art, it's about experiencing it, interacting with it, and becoming a part of it. With nanoparticles, art becomes a dynamic, interactive experience. The canvas is no longer a passive recipient of the artist's brushstrokes, but an active participant in the storytelling. And we, as viewers, are no longer mere spectators, but integral parts of the artistic process. Of course, creating nano art is not without its challenges. The tiny size of nanoparticles, less than 100 nanometers across, makes them difficult to manipulate and control. They're so small, in fact, that they can only be seen under a powerful microscope. This poses a significant hurdle for artists who are used to working with tangible, visible materials. Moreover, nanoparticles are sensitive to environmental conditions. Factors such as temperature, humidity, and even slight variations in light can alter their properties, potentially affecting the final appearance of the artwork. Protecting the nanoparticles from these influences, while still allowing them to interact with light to produce vibrant colors, requires a delicate balance. But don't worry, these challenges haven't stopped the art world from embracing nanotechnology. Quite the contrary. R is the radius of the quantum dot. This equation tells us that the energy of light emitted by a quantum dot increases as the size of the quantum dot decreases. So, in a nutshell, quantum dots are all about playing with the sizes to see a fascinating light show. Now, let's shine some light on photoluminescence. You might be wondering, what is this fancy term? Well, in the simplest of terms, photoluminescence is all about how things glow. Yes, you heard that right. It's the reason why certain things glow when you shine a light on them. Now, let's bring back our nanoparticles, the quantum dots. Remember how we said they change color based on their size? Well, this color change is all thanks to photo. This interaction between light and metal nanoparticles results in extraordinary optical properties, which can be manipulated to our advantage. To understand this better, let's look at the basic equation that describes LSPR. It goes something like this. Lambda res equals constant times the square root of epsilon m over epsilon d. Here, lambda res is the resonant wavelength or color of light. Epsilon m refers to the properties of the metal, and epsilon d is about the properties of the material surrounding the metal particle. This equation essentially tells us that the color of light that the metal particles resonate with can be altered. How? By changing the properties of the metal or the environment it is in. Think of it like tuning a guitar. Just as you would adjust the tension in the strings to hit the right note, you can tweak the metal's properties or its surroundings to tune the color of light that the metal particles reflect. And just like that, with a little bit of science, we find ourselves with a whole new palette of colors to play with. In Plasmonics, by tweaking the metal's properties or its surroundings, we can play with the color of light that the metal particles reflect. To put it all together, we've ventured into the fascinating world of quantum dots, photoluminescence, and plasmonics. We've learned that quantum dots are tiny particles that change color based on their size, with smaller dots emitting bluer light and larger ones radiating a redder hue. We've delved into the process of photoluminescence, where substances absorb light and then glow in a different color. And we've explored plasmonics, the science of using tiny bits of metals to catch and play with light, altering its color. The magic lies in the equations and their understandings, which act as guides, helping us manipulate the size and composition of quantum dots and metal nanoparticles to achieve desired colors and effects with light. The power of these concepts opens up a whole new canvas for artists, enabling them to create dynamic and captivating light-based artworks. These concepts, while complex, are the gateway to exploring new realms of creativity, enabling artists to create art that interacts with light in mesmerizing ways.